Hello, my name is Andrey Budzar, and welcome to today's session, Devsecops Change Control by Pull Request. Today, we're going to show you how you can enable self-service IT through GitOps. We're actually going to do things a little bit differently during today's session. We're going to start with a demo first. We're actually going to vend an AWS account that we are going to use later on in this session in order to create an Amazon VPC via pull request. Then we'll talk a little bit about Linedata and our DevOps journey and why we decided to go with GitOps. We'll talk about the definition of GitOps, what it looks like in practice, and as I mentioned, we'll finish up by showing a demo of creating an Amazon VPC through a pull request in Git. So first, let's go ahead and go into our demo. So I'm actually going to be using Harness for this particular demo. You can use any orchestrator that you choose. You can use Jenkins or similar. And I'm actually going to go ahead and request an Amazon AWS account. We will call this Unscripted. And we'll call it a sandbox. We'll do an Eng type of environment. This has some implications on the back end. We'll call this for asset management. I will be the resource owner. I will be the resource manager. And the description of this account is for Unscripted conference. And so we're going to go ahead and submit this. And there's a couple approvals that we're actually going to have to go through. So we'll go ahead and let this run through a few approvals and get the account started. And then we'll go back to our session. So the first thing that's going to happen in this pipeline is that there's an actual approval. Is this account approved to be created? So I'm going to go ahead and say approved. And we'll go ahead and approve this pipeline. Now, there's a couple things that are going to happen here. The first thing that it's going to do is it's going to create a email distribution to be used with Amazon organizations. So that way it can assign an email address to the account. Then it's going to run through some PowerShell scripts communicating with our Active Directory to set up some users and some groups, and as well that distribution group. It's going to set up a branch in Git that Terraform is going to use to actually create the AWS account. And it's going to set up the Harness environment that is going to be needed in order for Terraform to be able to target the environment. That environment actually happens to be the account name that we just created. And then finally, it's going to go ahead and execute another pipeline through GraphQL. So we're going to go back into deployments, and we're going to see that another pipeline has been executed that is going to create the actual AWS account. And so what this pipeline is going to do is it's going to create the account using Terraform. First, it's going to run a Terraform plan to make sure that everything is good. So we'll just give that a few moments to go through the Terraform plan. It's going to review that. Next is another approval. Once the plan has been verified, then somebody actually has to approve it. Now, I can approve it through the console, or I can actually approve it in Slack. So I'm going to go ahead and approve that in Slack, and you'll see this is going to go away and it's going to proceed to the next step. The next part that it's going to do here is that it's actually going to create the AWS account. So it's going to go through and it's going to use Terraform to communicate with AWS organizations, and it's going to create the account that I had just requested. You'll notice that it's using an email address that was automatically generated, and the account ID and all the other information is not going to be available until the account is actually created. So now it's just going to output some information about the account. We're going to destroy this afterwards, so not too concerned about the account ID. Then it's going to run through a few more PowerShell steps. That's going to run some Microsoft System Center orchestration, some configuration that's needed in our Active Directory in order to set up the account. Then it's actually going to set up a Git branch so that way we can deploy the IAM roles that will allow me to log into the account. When the account is first created through Terraform, it's a blank account. There's nothing in it. So the only way to be able to log into it is if you log into it as the root user. But we don't want to log in as the root user. We want to use our ADFS and we want to MFA to have to log into the account in order to be able to do something. So this step here is creating the IAM roles, again, through Terraform. So what it did was it's creating all of the IAM roles and ADFS connections that are needed in order for me to be able to log into the account, all the IAM roles that are needed, and for the account to actually function. And again, there's another approval here. So we'll go ahead and approve that and make sure that it's good to go. Now that this is approved, this is going to finish up this part of the demo where it's going to create those IAM roles and allow me to log into the actual account. So at this time, we're going to go back into the presentation and we'll go ahead and get started. We'll start with a little bit about Linedata. So we are a financial services fintech company. We offer front, middle, and back office products for wealth managers, risk management, lending and leasing. Essentially, we are a fintech company. We are global. We have many offices around the world, and 20 offices, in fact, with hundreds of clients and over 1,300 employees. And over the past couple years or so, we've been going through a digital transformation. We've been going into microservices, DevOps methodology, domain-driven design, CQRS, and event sourcing. Me personally, I am leading the certain aspects of the transformation as the director of cloud platform and DevOps. And as you notice, we have a global presence. And so we have developers and operation teams all over the country. So being able to allow our dev and operations teams to work more closely together to be able to collaborate and enable self-service was a huge understatement for us in order to move forward with our digital transformation. DevOps at Linedata took us a little while for us to refine the type of team topology and culture that we wanted. And, you know, a lot of organizations, when they first try to implement DevOps, more often than not, the first thing that happens is that, well, we're going to create a DevOps team and we're going to give them a bunch of tools and they're going to write a bunch of automation and everybody's going to become super productive. Well, unfortunately, you know, more often than not, that doesn't really work out. What you end up with is another silo that wrote the scripts and they're the only ones that know how they work, the only ones that can execute them. And as your organization scales or as more people start to onboard to the new services, microservices, the cloud, you end up with more and more feature requests, more scripts that you have to write, more scripts that you have to manage. And so this team, you now have to scale. And what you've actually done is you've alienated the dev and the ops teams. You've put another team in the middle that you now have to scale, and you've added, you know, more operational overhead. So, you know, this might work for the first 3 to 6 months, but it is not a long-term strategy because you're just going to have to manage another team. We knew at Linedata that we wanted to do something different, right? We wanted to focus on self-service. Now, DevOps itself has gone through many iterations since inception. More recently, Devsecops has emerged. And essentially, What this means is embedding security into the delivery pipeline, both for software and infrastructure. The cornerstone of DevOps is obviously continuous delivery and the ability to quickly roll out new features. However, through infrastructure as code, you can embed security into your infrastructure and automate the provisioning of your cloud accounts, your networks, your storage, your cloud services, your EKS clusters, anything that is needed for your application to actually function. Machine learning and artificial intelligence allows for continuous intrusion, anomaly, and malicious activity monitoring, as well as auto remediation. And for continuous delivery, automated code scans, CVEs, and penetration testing can all be done as part of the software delivery lifecycle. And finally, through software-defined infrastructure, compute capacity, auto scaling, even purchase options, right? Whether it's spot, on demand, reserve, all of that can be defined as code, managed in your infrastructure as code, and be defined as part of the software lifecycle, just like the deployments themselves. And all of these processes culminate into a self-service operating model. The goal here is to remove dependencies or interdependencies between teams and allowing for full autonomy that allows you to accelerate your feature development and innovation. Instead of spending time creating infrastructure or doing repetitive tasks, you want to focus on what the business does best, which is writing code that helps either internal or external customers and delivers value for the business. And a big part of that is how we decided to organize as a company for our DevOps model. What we decided was we combined the Google SRE model with the infrastructure as a service model. So what does this mean? So at the group level, which is kind of a global responsibility, we have the platform team, which I currently lead. The platform team is responsible for developing as code frameworks and modules that are then reusable by every single business unit within Linedata. So we have multiple business units. We have capital stream. We have asset management. We have multiple business units that require us to work in the cloud and deploy microservices and pods and cloud services. And we wanted to make sure that all of these teams were able to function self-sufficiently, but were also didn't have to repeat work from other different teams. So we wanted to develop these reusable modules that then all of these other teams will be able to consume and reuse. The SREs in a typical Google SRE model are responsible for running production. And the dev teams are responsible for writing and testing code and shipping artifacts that are going to be deployed into our production environments. Now, DevOps is not an actual team in this scenario. It's a function within the dev team. And so there's multiple individuals that might be responsible for the quote unquote DevOps function, which is, automating repetitive tasks, working on continuous integration, continuous delivery, and, more importantly, consuming the frameworks that come out of the platform team. Now, as we began to scale, however, we realized that, having this team that writes all the code is great, but once the code actually gets to production, who is going to manage changes to that code? So for example, you deploy a Kubernetes cluster and you need to modify the instance size, or you need to add more nodes. Or let's say you deploy a VPC in AWS and you need to add a security group, or you need to change network ACLs. You need to add a KMS key. You need, anything that you need to do in running production environment, all of that has to be done by someone. And so we were using infrastructure as code, But in our model, we had one team that was able to execute on that infrastructure as code. We wanted to enable the rest of the business to have the same type of self-service capability of infrastructure as code as they did with software deployments and software delivery. So we needed a new operating model for managing that infrastructure as code. And so what we came up with, and not something that we came up with, but in the industry, there is something called GitOps. Now we implemented our own version of GitOps, but the principles that we followed are the core principles of GitOps that were developed by Weaveworks. GitOps, as its, in its core, describes the desired state of the whole system, and it uses a declarative language. A Git repository now becomes the single source of truth for the desired state of the entire system. So whatever is in the code, that is the state of the system. And any changes to that state requires a pull request and a Git commit, right? So anytime you want to change that state, you want to add new code, requires you to commit a change to that code. Now, when you open that pull request and you have a desired state, you now have a difference between what's observable, what's observed, and that is what's in the code, versus what your desired state is, which is your pull request. Once you have that difference between observed and desired, there is a convergence mechanism that brings the desired and observable states in sync. Both eventually and automatically. And this can be triggered immediately or manually when an approved change is committed. So when I open a pull request, my pull request is approved, then my change is committed. The system should then be able to converge what the change is to what was there before. And if there's any sort of changes at a configurable interval, you can have an alert that says, hey, what you have in code is not what is actually running out there. And that will allow you to then go through the convergence process. And all of these Git commits cause a verifiable and idempotent update to the infrastructure. Essentially, you cannot change the code after it's been committed. If you need to change something or you need to revert, you need to create another commit, right? So all of these changes are trackable and auditable, and you cannot change them after the fact. And we'll talk about, what happens if you put a change into production and then you need to revert that change. So the operating model is fairly straightforward, right? So you have Git as your source of truth. You have your diffs between your observed state and your desired state. In our scenario, we use Terraform. So in Terraform language, that is considered a Terraform plan. All of your intended operations are committed by pull request for all environments, whether it's dev, QA, staging, production, any environment is changed through a pull request and committed in Git. And all of those diffs between Git and the observed and desired state lead to that convergence. Again, in Terraform language, that is called a Terraform apply. So as you noticed during the demo, I had a Terraform plan, which is my desired state. I had an approval, and then I had an apply, which is going to be my observed state once the plan is approved and committed. And all of these changes are observable, they're verifiable, and they're audited with the ability to roll back. Using Git, you have a full audit trail of every single change that was made, who made it, why they made it, when it was made, making it very simple to pass SOC audits if you are required to do so. So let's talk a little bit about what GitOps looks like in practice and how we at Linedata have implemented GitOps in order to enable self-service for our engineering teams for our infrastructure. Our ecosystem revolves around, obviously, Git. which manages the pull request and has role-based access permissions on the repositories, has branch protection, who can open a pull request, who can make an approval. All of that is done with Git to give us granular control over the actual repos and the code itself. We use Terraform to execute our infrastructure as code. Now, the reason that we chose Terraform is because Terraform is declarative, and Terraform maintains that state for you in a state file. And your state file is the observable state of your infrastructure, and then your pull request is that desired state that you want to get to. And because it's declarative, Terraform figures out how to get to the observable, from the observable state to the desired state. That could either mean destroying and recreating something, it could be changing something in place, or it could be making something new if it doesn't exist. So the main reason that we chose Terraform is because of that declarative language that Terraform is known for. Harness happens to be our orchestration engine. Now, I know this is a Harness conference, but you don't have to use Harness. You could use Jenkins. You could use other tools in order to do the actual orchestration, but at Linedata, we use Harness. And then finally, our infrastructure that we're actually going to be deploying to is AWS. So what does this actually look like in practice? I know this is a busy diagram, but we'll kind of follow the numbers sequentially. So if somebody needs to request a change, in traditional change control, traditional infrastructure, you might put in a ticket, right? You might have to go back and forth with IT, and then you wait. Then you might have to clarify something. Then you might have to wait some more. And then maybe 2-3 days later, you'll get what it is that you actually asked for. Well, instead of doing that, what you can do using GitOps is that you can actually open your own pull request. So if you have the skill and the knowledge and the permissions, you could log into Git. You can open up the repo where the code exists, select the appropriate branch, and request your changes by making your own branch and opening that pull request. If you don't have the skill, or you don't know exactly how to change something, you could still go the traditional path in creating a ticket, and then somebody will go ahead and create the pull request for you. But obviously that's going to take longer because they'll be addressed in the order and priority that they come in. So, step one, open a pull request. If you can't, step two, step 1B, create a ticket. Now, the second thing that happens is that when you open that pull request, Git automatically triggers a Terraform plan. So what it does is it actually executes a Harness workflow that executes a Terraform plan and checks to make sure that your syntax is valid. There's no errors in the plan. And then it publishes the results of the plan back into the comments of your pull request. Once that happens, you can review your plan if there's any issues with it, if you made a mistake, if there's errors, if there's any sort of syntax errors, or if you're using a third-party tool to do static code scan analysis of your infrastructure as code. There are tools now that allow you to do code scans of Terraform code to make sure that they're compliant. But once you're happy with your pull request, you can go ahead and request for somebody to approve it. Once somebody reviews your code and approves it, then they're able to merge your change. And at that point, the automation to converge the desired state with the observable state happens. And so what happens is that Git then triggers another Terraform execution, but this time it executes a Terraform apply based on the commit that was just made from the PR that was approved. And in our scenario, what happens is that all of our Terraform is executed through a central AWS account that allows us to maintain all of our permissions, role-based access control, our AWS IAM policies and roles about, which roles can do what. And so through cross account, we actually go ahead and execute on that change. So in your code, you'll have a target account and the harness delegate, which is executing these changes, which lives in the DevOps account, is then going to assume a role that is predefined and existent in the target account and execute on the change that you requested. Now, because Git requires you, or GitOps requires you to maintain everything in code, you want to avoid doing any changes manually. Because if you change something manually after the fact, you can no longer maintain the consistency or the integrity of the system, right? Your observed state is no longer the observed state that it is in code. However, there might be scenarios in a break fix scenario or in a production outage or something where you have to do something manually. And so in our situation, we allow that. However, we trigger an alert. So our process is defined such that everything goes through Git. However, in a break glass scenario, you can do something manually, but that will trigger an alert. We use AWS CloudTrail and a Slack notification that then triggers that somebody did something manually, that Terraform didn't do it. And then we'll go ahead and review that change, make sure that it was justified, go through the process, find out why it was made, and then make sure that it gets applied into the code. So that way there is no difference between the observed state that's in the code versus the observed state that's actually running in the environment itself. So I know I talked a lot about, the GitOps kind of concepts and how all of this works. So why don't we go ahead and actually show you guys how this concept works in real life scenario. So you'll notice that the AWS account that I created earlier is now complete. So the Terraform apply finished. I have all of my resources that have been created. So I am actually now going to go ahead and create a VPC in that account by opening a pull request. So what am I going to do? So we have a repo for sandbox accounts, and there's an actual template in here that is predefined and has some documentation as far as how to use it. I'm not going to go through that in detail. So we're going to go ahead and create a branch that is a clone of the template. Now, when I create this branch, nothing happens, right? All I did was clone a branch, and now I have to go and fill in some information that will actually allow me to execute on this code. So the next thing that I'm going to do is I am going to create a patch branch. So I am going to call this. So I'm going to create my own branch. Now I can go ahead and work inside of this branch. Now, from the documentation, I know that there's some variables here that I need to fill out. So I know that I need to change the AWS account number, which is available here. And I am going to call this a sandbox environment. And this is for unscripted. So I'm going to go ahead and commit these directly into my branch. So I'm just going to add account ID and changed bars. So just go ahead and make that comment. Now I need to add a few more variables. I need to set up my actual subnetting, right? My VPC CIDR, my public private subnets, etc. So I'm going to go ahead and create the actual CIDRs. So I had already pre-populated, so we'll make this a little bit quicker. So populated subnet vars with appropriate CIDRs. So now I'm going to go ahead and commit into my branch. So now I am done, right? I set up the vars, and now I want to go ahead and execute on this VPC. So I'm going to go ahead and I'm going to open a pull request. My base branch is going to be the one that I created from the template. It has base code in it, but I didn't fill out any of the variables. And I'm going to compare my desired state, which is the new branch that I just created. So I want to deploy a VPC in so now I'm going to go ahead and create my pull request. So because I'm an administrator, I can actually merge this by myself. However, in an actual production scenario, you would set up branch protection so that the administrator can't push their own changes, and that requires approvals from certain people before you can actually merge that commit. But for the purposes of this demonstration, and because I'm doing this by myself, I allowed myself to be able to merge my own commit without having to go through the branch protection rules that would normally be in place. Now you notice that I have a comment here from Harness, which is the auto pull request, which is going to execute on the plan that I just put in for all the variables that I populated within that code. And you can see that the plan passed. Right? So while I was talking, the plan already passed. So I can see that there's no state file. This is a brand new account. I can see that I'm going to be creating a bunch of resources here, and I can go through each, review all of them, make sure everything's good. I'm adding 104 resources. I'm not changing anything, and I'm not destroying anything because nothing existed. Great. Now I'm going to go ahead and merge my change. And so what this is now going to do is this is going to get us one step closer to executing on the desired state that I want based on the changes that I have submitted as part of my pull request. So again, in a few moments, I will get another comment, and this is the automation piece of it. Now that I've merged the changes, I'm going to actually go ahead and apply those changes through automation. Now, again, it's going to go through a Terraform plan because you want to make sure that anytime you execute, you get the latest code and you refresh the plan to make sure that there's nothing stale that's caught in that plan. So again, you just want to review that real quick, and then comes an approval to be able to execute on that change. Going to go ahead and approve that in Slack. And now it's going to execute the Terraform apply to create the VPC from the pull request that I just made in order to execute on that new code. So we'll go ahead and let that run, and we'll go back to the presentation. So, as you can see, or at least I hope you can see that, there's a lot of potential benefits to GitOps, but it's not without its challenges. First and foremost, you have to design and implement the system, right? You have to configure your Git repos, your branches, your branch protection, your role-based access control, your webhooks, your GitHub actions. You have to configure the system. And depending on the orchestration engine you use, it might be, easier or it might be harder. I can tell you that with Harness, it was super simple for us to set up. A lot of the GitHub triggers were already supported. And so it was pretty straightforward for us to set up this process. There can be a steep learning curve. After all, if you're allowing engineers to open pull requests for infrastructure, then they're going to need to know about infrastructure, right? They're going to need to know about networking. They're going to need to know about AWS services, IAM, EKS, KMS, S3, right? If they're going to write code and they're going to request changes, they're going to need to know, the system that they want to change. But that's not, that's not a bad thing, because that enables collaboration and learning opportunities and fosters a true collaborative DevOps culture, which we'll talk about in a second. And then finally, it requires discipline, right? If you're going to use GitOps and you're going to do everything through code, that requires you to be disciplined to not do things manually in the console. I mean, you can lock people out if you want to, but allow them to do things in a break-fix scenario. But it does require a certain amount of discipline in order to maintain everything in Git and in code, and can take some time getting used to. Especially from traditional IT folks that might not be familiar with, with Git, with source control, or writing code. However, the benefits are tremendous, right? You get self-service IT. This alleviates the burden of having all of your tickets, all of your changes being not only executed by written, but written by the same team, and allows you to spread the responsibility and really allows you to scale as an organization. We at Linedata have dozens and dozens of AWS accounts that we manage through GitOps, following the same exact process, and we're able to manage all of those accounts without any delays to those requests. It has transparency. Everything that was done is in code. That code is available. You can view that code. You don't have to ask somebody, well, what did you do to fix this? Or what did you do to implement this? Well, you can see it because it's in the code. And your code now becomes your documentation. You don't have to write these, elaborate documentation, because the code, being declarative, is in itself the documentation for the system. And like I mentioned, the collaboration between development and operations, right? In order for DevOps itself to work, developers have to learn about operations, and vice versa. Operations folks have to learn about development. So that means that IT, learns source control and learns how to code and learns scripting languages. While at the same time, development needs to learn about networking and security. And this allows both teams to collaborate and increase the velocity of your DevOps transformation. I mentioned scalability, right? Sharing the load amongst multiple engineers instead of centralizing the work within one team that you then have to manage. And security, right? Because everything is code, you can embed security directly into the code. So whether it's enforcing encryption or VPC flow logs or load balancer logs, IAM roles, because everything is defined in your code, you can now embed that security directly in that code and not have to, and it's not something that you have to worry about after the fact, right? Oh, we'll do this now, we'll secure it later. Well, no, you don't have to. You can write it into the code from the very beginning. And finally, you get that increased return on investment, right? The more people you get to collaborate, the more you can spread the responsibility, the more you're able to scale, the faster you're able to move, and the quicker you're able to deliver on new functionality, because you're spending less times on executing on repetitive tasks. So I wanted to now step back to the demo really quickly, because I promised you guys I would show you how to do a revert. So if, let's say that I want, something went wrong with this and I wanted to actually revert my change. Well, there's a revert button right here, right? So because all of the commits are stored in the Git history, and you see exactly what was changed in that commit, I can actually go ahead and revert that commit. So when I go ahead and revert, I'm going to create a new pull request, right? I mentioned pull requests are idempotent. You can't change them. So in order for me to revert my changes, I now have to open a new pull request, which is then going to trigger the process all over again from start to finish, and I have to go through the same process in order to then execute on that revert and put back what was in there originally. Thank you so much for joining this session. I hope that was informative and helpful, and I hope that you enjoy the rest of the Unscripted conference.